Hi everyone. So we're just going over homework. Besides the answers, I would like you to just make sure that you're using the right technique of substitution. So in the first equation, in the first system, you have y isolated in the first equation. This should have subbed in for the place of y here. You should have had 2x plus x minus 4 equal to 5. And then from there you solve. I'm not going to show you all the work. The final solution should have been 3, negative 1. Okay. In example 2, the x is isolated, so this expression should have subbed in for x in the first equation. 2 times y plus 4 minus 5y equals 8. You solve for y, plug it back in, find x. You should have had a solution of 4, 0. So there are other ways of doing this that are more lengthy. The way I'm showing you right now is the most efficient method, and it's the way that I would like you to do it. Okay. Example 3, both have y isolated, so you just have 4x minus 8 equals 2x plus 10. And when you solve for x and y, you get 9, 28. Going to the next page, number 4, the y is isolated, so x plus 3 should have subbed in for y in the first equation. So 3x plus 2 times x plus 3 equals 26. And then when you solve for x and y, you get 4, 7. Now, if you notice that you're not using these methods, or that you're using fractions in your substitution, that's telling you that you need to go back and use a different method. You shouldn't be working with fractions because it just takes longer and it leads to the possibility of more mistakes. Okay, example 5, y minus 1 is going to sub in for x in the second equation. Be careful here because it's 4y minus, and you have to use parentheses. You're subtracting all of y minus 1, which means you're going to distribute that negative, equal to 19. So when you solve for y and then for x, you're going to get 5, 6. In example 6, none of the variables is isolated, but as we mentioned yesterday, you want to solve for the variable that has a coefficient of 1, and that would be the x. So I'm going to add 3y, and I'm going to have x equals 3y plus 1. So now I take this expression, sub it in for x in the second equation. So 5y minus 2 times 3y plus 1 equals 1. And then from there, I'm going to solve for y, then plug in for x. Negative 8, negative 3 should have been your final solution. Feel free to pause the video as much as you need. And then the last one, sorry, not the last one on this page, the coefficient 1 could be found on the y in the second equation. So I'm going to subtract 9x. So I have y equals not 20 minus 9x, or negative 9x plus 20. This is going to sub in for y in the first equation. I have 3x plus 3 times 20 minus 9x equals 12. Solve for x, plug in for y. You're going to end up with 2, 2 for your solution. On to the next page. We're going to solve for the x in the second equation, again, because it has a coefficient of 1. So we're going to subtract 4y. X equals negative 4y minus 4. This substitutes for x in the first equation. So you should have 3 times negative 4y minus 4 plus 5y equal to 2. And then when you solve for y and x, you're going to have 4, negative 2 for your point of intersection. Number 9, the x is isolated for both, so all you have to do is take these two expressions and set them equal to each other. So you have 3y minus 10 is equal to 8y plus 5. And then when you solve from there, negative 19, negative 3 was your point of intersection. Number 10, I'm going to isolate this y because it has a coefficient, well, it's negative 1, but if I add y and then add 2, I'm going to end up with y equals 4x plus 2. And then I will sub in this in the place of y in the second equation. So negative 2x minus 3 times 4x plus 2 equals 1. Solving for x and y, you're going to end up with negative 1/2 comma 0 for your solution. And then finally, you had the option, you could have easily isolated x or y, it doesn't really matter. I'll solve for x, y equals negative x, sub this in for y in the second equation, so 5x plus 2 times negative x, which is just going to be negative 2x, equals negative 3. And then that gives you 3x equals negative 3, and so your final solution is negative 1 comma 1. Okay, so hopefully this helps, and today we're going to look at a different method of solving algebraically.